Welcome to solverfy.
When you're given a quantity, either mass, moles, or atoms, it's helpful to create a roadmap or a plan to change from one to another. They all are the same amount, they're just being measured in different units. If you have mass, you can change to moles by using the molar mass. Remember, the molar mass is found using the periodic table, and the molar mass, the atomic mass, is the number below each element. So to find the molar mass of anything, we simply add up the molar masses of those. So if you have mass and you want to go to moles, you divide by molar mass. If you have moles and you want to go to mass, you multiply by the molar mass. If instead of looking at mass, you're looking at atoms or molecules or particles, we use Avogadro's number. If you have atoms and you want to change it to moles, you can divide by Avogadro's numbers. And if you have moles to atoms, you multiply by Avogadro's numbers. You can also go from mass to atoms or vice versa by always changing to moles first. So if, for example, we have a certain amount of moles of a substance, 6.44 times 10 to the minus 2 moles of MnSO4. And we want to know how many grams that equals. We're starting at moles and changing to mass, so we need to multiply by the molar mass. So we have moles that we multiply by molar mass to get grams. To find the molar mass, we use the periodic table and we look up the molar mass of each substance. So we have the mass of Mn, which is 54.938, plus the mass of sulfur, which is 32.06, plus 4 times the mass of oxygen. And this gives us a total molar mass of 151.00 grams per mole. So to find the equivalent, we multiply 6.44 times 10 to the minus 2 moles for every 1 mole. It's equal to 151.00 grams. So this has a mass of 9.72 grams. You could start instead with a mass, so let's say 15.8 kilograms of a substance, FeClO4 and change it to moles. So if we have mass in kilograms, we need to change it to mass in grams. And then we need to change to moles. And we do that by knowing that 1 kilogram is equal to 1,000 grams. And we use our molar mass. So if we have 15.8 kilograms, we change it to grams by multiplying by 1,000. And then to change to moles, we multiply by the molar mass. So 1 mole. And using your periodic table, you find the molar mass of this substance to be 354.20 grams. So if we take 15.8 times 1,000 divided by 354.20, we find that it's equivalent to 44.6 moles. Another example in which you have to be careful of looking at what the question is asking is if we have a certain mass of a substance, so 92.6 milligrams of NH4NO2, and we want to know how many atoms of nitrogen are present in this compound. So we have a molecule, and we're looking at the number of nitrogen atoms using the formula. So we'll start off with milligrams, which we have to change to grams. Once we have grams, we can change to moles. Once we have moles of our compound, we can change to molecules of the compound. And then using the chemical formula, we can find the number of atoms of nitrogen. So to go from milligrams to grams, we know there are 1,000 milligrams in every 1 gram. From grams to moles, we'll use the molar mass. From moles to molecules, we use Avogadro's number. And then finally, we use the chemical formula to see how many atoms there are in every molecule. So 92.6 milligrams for every 1 gram, there are 1,000 milligrams. Using the periodic table, we find the molar mass. And every 1 mole of this substance has a molar mass of 64. 64.06 grams. And in every mole, we know there are 6.02 times 10 to the 23rd molecules. And finally, if we look at the formula, there are 2 nitrogen atoms for every 1 molecule. So by multiplying 92.6 times 6.02 times 10 to the 23rd times 2, and then dividing by 1,000 times 64.06, we see that there are 1.74 times 10 to the 21st atoms of nitrogen.